Imagine you have a super fast spaceship, almost as fast as light. When you look out the window of this spaceship, things outside seem to happen faster than normal. This is because of a special effect called relativity, which was discovered by a scientist called Albert Einstein. To understand this better, think of sunlight. Normally, it takes about 8 minutes to travel from the sun to the Earth, a distance of approximately 93 million miles. Now, if you were in a spaceship traveling very, very fast, say 90% of the speed of light, that same sunlight would take less time to reach you, approximately 3.5 minutes. And the distance the light would travel would be less, just 40 million miles. This means that somehow by traveling so fast, you are seeing time differently from someone who is stationary on Earth. If you were traveling in a spaceship at different speeds, the distance from the Earth to the Sun would look different. As you approach the speed of light, that distance seems to shorten. The big question is, the faster you travel, the less time things seem to take. If it were possible to travel at the speed of light itself, which in practice we can't, light would arrive at its destination instantaneously, meaning you wouldn't notice time passing. Einstein called this the theory of restricted relativity. It shows that time does not pass equally for everyone. For those traveling at extremely high speeds, close to the speed of light, time passes more slowly than for those standing still. That sounds strange, doesn't it? But it's one of the most fascinating ideas about how the universe works. It's as if, for light, and everything that moves with it, the concept of time as we know it doesn't apply. The important point here is that although distance and time seem to change depending on how fast you're moving, the speed of light remains the same for everyone, around 186,000 miles per second. This is a fundamental principle of Einstein's theory of relativity. The speed of light in a vacuum is a universal constant, no matter how fast you are moving. An even stranger point arises when we talk about traveling at the speed of light itself. If it were possible, and according to the laws of physics, it isn't, for objects with mass, time would basically stop and distance wouldn't change from the point of view of light. This means that for light traveling from the sun to us, no time passes. It arrives instantaneously, even though we perceive it as an 8-minute journey.
The idea that nothing with mass can reach the speed of light is because that would require an infinite amount of energy, which is impossible according to the laws of physics as we know them. In short, the speed of light is constant and doesn't change, no matter how fast you're moving. Perceptions of time and distance, however, change as you move faster, but reaching the speed of light is a limit we can't cross. And if we could, time and space as we understand them would no longer apply, which is a very difficult and fascinating concept to imagine. This theory teaches us that time is not a river that flows at a constant speed, but rather a malleable fabric that stretches and contracts.
But what does this really mean? And how does this affect our perception of the universe? Imagine, for a moment, that your day-to-day life is governed by rules that allow time to speed up or slow down, depending on how fast you move. Think of the implications. Space travel that leads us to age less compared to those who stay on Earth. Satellites that need to adjust their clocks to synchronize with ours due to their high speed.
Einstein didn't just give us equations and theorems. He gave us a new way of dreaming about the cosmos. With his theory, we are instigated to imagine parallel universes, wormholes that allow us to cross galaxies in the blink of an eye. And even the concept of time travel becomes a topic worthy of scientific discussion, and not just science fiction. Now imagine these photons, tiny particles of light, embarking on a journey through the vacuum of space, originating in the very birth of the universe, in the heat and energy of the Big Bang. For these particles, concepts such as past, present, and future blend together. They experience eternity in the blink of an eye. Imagine the trajectory of these cosmic travelers, crossing galaxies and gliding across planets, all in a fraction of a second that, for them, spans millions of years. These photons, bearers of the light that illuminates the cosmos, do not perceive the passage of time as we do. And so, after a journey that would be inconceivably long for us, they conclude their cosmic odyssey. Their final destination may be the surface of a planet, the retina of an observing eye, or even the mirror of a telescope, capturing an image for us to marvel at. This contemplation leads us to a deeper appreciation of the complexity and beauty of the universe, an invitation to recognize our place in the cosmic vastness. The journey of the photons is a reminder that, on some fundamental level, we are all connected through light, time, and space, dancing together in the infinite choreography of the cosmos. So, as we contemplate the wonders of the universe, remember, the adventure has only just begun. Are you ready to unravel the mysteries of time and space with me? Thank you very much for following me here. See you next time.